All right, welcome back. Today we're going to talk about area of triangles. Now, triangles are a little bit different than squares, rectangles, and parallelograms. However, they're also very similar. So we're going to use concepts covered in both of the other lessons and kind of combine them to generate our formula for calculating the area of a triangle, as well as how to properly estimate the area of a triangle. So just like before, at the very top of our page, we have two different triangles that are overlaid on top of a grid. Now, each of the squares in the grid are supposed to represent 1 centimeter squared. So what I always recommend doing is counting how many total complete squares are inside of our triangle. And then once you have that, figure out the parts that can be combined to create full squares after that. So if we look at this, we have 1, 2, 3, 4. We have 4 complete parts. And if we're looking at this, I would say that this one kind of combines with that one up there. So we have 1 more centimeter squared. And this one can combine with that one. There you go, another centimeter squared. This one and this one kind of look together, so 1 centimeter squared. And yeah, that one kind of goes with that one. So another centimeter squared. And so we can add all of these up. So we have 4 plus 1, so that's 5, 6, 7, 8 centimeters squared. And again, it's an approximation. It's not an exact number. So we indicate it with, excuse me, with kind of a squiggly line right there. Now for the next one, it's going to be a little bit more difficult because this triangle has a line bisecting many different squares. And we can approach it the same way, though. We can go and calculate our full squares. Now, I'm going to cheat a little bit, and I'm going to go squares that are mostly complete. I'm going to go and count as well. So I have 1, 2, 3, 4, 5, 6, we'll say 7. So we're going to start with 7 centimeters squared. And then we're going to kind of look at our different parts here and say, what can I combine to kind of create this? Now, when I'm looking at this one, I'm saying, well, this one kind of combines with this one. Yeah, that piece kind of fits in right up there. And that little piece, yeah, that can go in right over there. So we have 1 more centimeter squared. And now what we're missing, well, this chunk right here. So we have a little bit right there, a little bit right there, and a decent sized one over here. So let's add another one in there. So that one can kind of combine with this one. And let's actually say, let's go with that one there. So you have another centimeter squared here. And now when I'm looking at it, I'm going, well, you know what? That's pretty much it. I think we've actually got them all kind of accounted for here. And so we can add those up. So we would say that it's approximately 7 plus 1 is 8, plus 9. Well, you know what? I missed one. Let's go back here. This one and that one. And there's a little piece there and that one. I did miss one. So we have 1 more centimeter squared, which gives me an approximation of 7 plus 1 is 8, 9, 10 centimeters squared. Now again, it's not exact. That's an approximation. If you had said 9, you've been pretty close. Okay, so now we're going to talk about how do we calculate the formula for our area of triangles. Now you'll notice that when we have two triangles, two of the same triangles, and with one of them flipped, kind of rotated along this point right here, it actually does create a parallelogram. Now, if you remember back in the other lesson, we talked about the area of parallelograms, and we discovered that the area of a parallelogram is the base multiplied by the height. So we can apply this information, this rule, to our parallelogram right here. So our base would be this distance right here. And our height, if we look back at it, was our distance from here to here. So we have our base times our height. But you'll notice that this is half we're talking about the triangle which is half of this size. Okay, so keep that in mind. And again, if we're looking at this one, we have our height over here and our base. And again, when we're talking about our triangle, we're talking about half of the area which was shown in our parallelogram or our square here. So when we're calculating the area formula for our triangle, it would be the same as our parallelogram, our base multiplied by our height, but we need to divide that by 2 because this is half of the area which was generated by our parallelogram. Now we can apply this on the questions down below. Just going to move that camera up. So we have some different values here. Now, just like before, we have different measurements that aren't going to be very useful to us. What we really care about is our base measurement. Our base in this question will be 3.3, as well as our height. Now, our height, again, is that measurement from the point here to the very tip here, but in a 90-degree angle. So for the first one, we're going to put our formula down here, which is area is equal to our base times our height, all divided by 2. So we get our base, which is 3.3 centimeters squared, multiplied by our height, which is 3.2 centimeters squared. And then we're going to divide all of that by 2. Now, when you do your calculation, you'll get that those two multiplied together gives us a value of 10 and 56 hundredths centimeters squared. But we still have to divide that by 2. And that gives us a final area of 5 and 28 hundredths centimeters squared. And we can work on the next one. So again, we're going to put our formula in here. Very important, we're always putting our formula when we're working through a problem like this. So base times height divided by 2. So our area, again, is equal to, in this case, our base is 4.3 centimeters multiplied by 3.4 centimeters. And we're going to divide all of that by 2. And when you do the calculation, you end up with a value of 14 and 62 centimeters squared, all divided by 2 still. And our final area, which comes out to being 7 and 31 hundredths centimeters squared. Now, if you do want to check this and see, does this all work? Is the area actually, based on this formula here, base times height? We can go back to the very top and we can check our answers here. So our base here is 1, 2, 3, 4. It's 4 centimeters. And our height is from this point to this point, which is 1, 2, 3, 4 centimeters. That's that distance from there to there. And we'll go from here to here. And again, you remember our formula was the area equals base times height divided by 2, which in this case would be 4 centimeters times 4 centimeters divided by 2, which is 4 times 4 is 16 centimeters squared divided by 2, which gives us a final area for this question of 8 centimeters squared, which incidentally is the same approximation we did before. And the same thing with this one. We can calculate the area of this one. Again, putting that information into our formula. Our base is 1, 2, 3, 4, 5. So our area would be base times height divided by 2, which is 5 centimeters times. Now, what's our height? Our height is all the way to the top. 1, 2, 3, 4. 4 centimeters. All of that divided by 2, which gives us 20 centimeters squared divided by 2. And 20 centimeters squared divided by 2 is 10 centimeters squared, which again is the same as the value on top there.